We are creating the living network with InterDigital. Dirk, tell me a little bit more about what you do.
InterDigital is a wireless technology company in the areas of 5G, wireless technologies, IoT, and we're active in many areas related to 5G, specifically here presented in the networking area and in the radio access millimeter wave area. But as I said, we also do IoT technologies, etc., which we're not demonstrating today.
Excellent. And talking of demonstrations, you've got something to show us here, don't you? Would you like to talk us through what we've got?
Yes. So this is the next generation networks demo, and what we're demonstrating here is to stem the costs in HTTP content distribution, which is like your standard Netflix, YouTube. You have a lot of people watching the same thing, but unfortunately, because of the underlying HTTP protocol, everything is sent to you individually, and that leads to a linear increase of costs, which is why Netflix is such a cost factor nowadays in the internet. And what we're doing in our demonstration is to allow content to be grouped together that is watched by the same people at roughly the same time, and to deliver the content in multicast, which means it's only sent to this group of people once instead of sending it individually.
That's very smart. I imagine that platforms like YouTube and Netflix that you mentioned are particularly interested in what InterDigital are doing.
Yes, absolutely. We see it as an evolution to standard content distribution networks as they're done today. So instead of distributing the content and still individually transmitting the content to individual users, we have the ability to distribute the content, but then distribute the content to similar users at the same time in multicast. We're also able to move servers around as the user changes the network, which is the second part of the demo that we're having as well.
Excellent. And I presume that's not been an easy path. Tell me about some of the challenges that you've overcome in finding this technology.
Well, the difficult part is really, as you can appreciate, that people are not synchronized. So the perception we are giving to end users is still that of you're sitting at home, you're starting your video, you can hit the pause button at any time. Your laptop runs a little bit slower than your neighbor's laptop. So all of these things, because of the lack of synchronization, it is very, very hard to do a multicast delivery. This is not like your live event being streamed to 1 million people. Everybody is watching. There's a sense of synchronization that doesn't exist here. It's still personalized viewing in your Netflix, with your YouTube, as you're used to at home.
Okay, and tell me a little bit about what we can see here as well, what information we can gather.
So actually the least of the demo is actually really here. Most of the demo is remote, so we're running a remote demo, and the main demonstration client is here. You can see that the schematic setup here, we have a video server on the right-hand side, which is actually near London, so the demo is relatively national. It is a bit more impressive if the demo is properly international because of the delay. But the video server is near London, and it plays out a video to 30 users which are very nearby in the same computer lab at the University of Essex. And there are 2 other devices here, as you can see here, that are at the actual booth. What happens now is that when we start the video, which I'll just do in a moment if you allow me to just press on this icon here.
And that's great to hear that the University of Essex are involved as well. So we've got some
It's an EU-funded project that runs among 16 partners. University of Essex is one of the partners. We have a content company in London as well, and then obviously European partners as well. So this comes from the University of Essex now. At the moment, you see the video is streamed down there, and it's coming now to this. What happens when I started the video, all the 30 users in the computing cluster were told to start watching as well. Now that is as synchronized as you can get it, because these 30 users will start watching whenever their computer starts, etc. So there is no strong synchronization, but the users watch at roughly the same time. What we are able to do with our technology is when the users ask for the content, we group the same content that needs to go to the same users into a single response and send this out. And you can see this at this visualization here. The green dots are all these 30 users, and the small little yellow one is the tablet that I just used for starting. And the number that is starting to count up, which is averaged over time, so you'll see it starts increasing, is the gain you're getting by being able to send more than just one response to every individual client. In your standard internet, you have 30 plus 1 users. You would have, for every time video is pulled, you have 31 responses. And that's what increases the cost. If you have 100 users, you have 100 responses. In our case, you'll see when this runs longer, you have, instead of 31 responses, you have in the order of 4 or 5 responses, but sent to all 31 users, and that's what leads to the increase. The second aspect of the demo that we're doing, and it already changed here, you see it says down there source surrogate. What we've done is, and again, you appreciate that is much more impressive when you have more delay, we've segregated now the traffic in having the 30 users continuing to watch the video at the original server, but we established a second server that is nearer to our layout device right here. And the video now comes from this so-called surrogate server. Now, we are at the moment, for instance, at the MWC in Shanghai as well, where we show the same demo, time shifted obviously. The demo is already over there. And in Shanghai you can see the benefit of this. The video, instead of being pulled half across the globe from London, based on the trigger of delay, the video is instantiated nearby in Shanghai, and the layout comes from Shanghai instead of from London, which obviously leads to much less latency and to therefore a bigger rate that you can experience. That's the traffic localization we're having.
That's great, and it's fantastic to get such a visual explanation as well. So Dirk, thank you very much for your time.
You're very welcome. Thank you.